Hi, welcome back to the channel. So we continue looking at question 11, and what we look at in this video is question 11b. Okay, so I'm going to leave the link for the video of question 11a in the description. Just make sure to say you watch that video before you watch this one, because there are some parts of question 11a that are already found. Like, we use the same process as in question 11b, but I don't want to waste time doing that because you already did that. So watch that video before you come to this one, then you will be able to understand what I'm writing and where it is coming from. Okay, so question 11b says determine the clamped cubic spline S that interpolates the data and satisfies S prime of 0 is equals to 1, as well as S prime of 2 is equals to 1. Okay, so how do we go about this one here? Okay, so from part A, like from the previous video, one thing that we came up with is the fact that a naught is equals to, it was equals to 0. Our a sub 1 was equals to 1. Then we also had some equations. Our b naught plus c naught plus d naught is equals to, it was equals to 1. Then here we had our b sub 1 plus c sub 1 plus d sub 1, which was equals to 1. Okay, so in this case I'm going to name this as equation 1, this as equation 2. Okay, what else? From the previous video again, we derived the fact that from the first derivative, okay, from the first derivative we had our b sub 1 was equals to b naught plus 2c naught plus 3d naught. Okay, that's what we derived from the previous question. That was from the first derivative. From the second derivative, we came up with the fact that our c sub 1 was equals to c naught plus 3d naught. Okay, so once again, this I can name it as my equation 3, then this as my equation 4. So this portion here was after we applied the interpolation conditions. This was after we applied the first derivative. This was after we applied the second derivative. Okay, what else? Okay, so here what we now do is to apply the clamped, because the clamped boundary conditions, because in the previous one we applied the natural boundary conditions. Now we just apply the clamped boundary conditions. Okay, what do they tell us? Okay, so for the clamped boundary conditions, I'll start with 1. Okay, and of course the boundary conditions, we are still looking at the interval, which is 0 comma 1 and 1 comma 1 comma 2. Okay, this one is for s naught, this is for s sub 1. Okay, so meaning you're just applying s naught at 0 and s sub 1 at what, at 2. Those are the boundary conditions, but what's different is that those from the previous video is for the natural like the natural conditions, but for these are clamped boundary conditions. So our s prime, okay, our s naught prime of 0, which is our initial boundary condition, this we say this is equals to what? This is equals to 1. Okay, this is equals to 1. So it's just like when you differentiate the equations that we had, when you differentiate them, then you evaluate this was equals to 1. Then what this tells us is that if you look at this, you have your s prime of 0 of x is equals to by the way, I know this might seem a bit off, but let me show you where this is coming from. It's actually been given in the question. Okay, so in the question I've been told to say first of all is at s prime of 0, meaning our initial boundary condition here, like here, initial boundary condition is equals to 1. Even our second boundary condition is equals to 1. So that's where I'm getting that one there. Okay, so that's what we are given. That's the first part about the clamped boundary conditions. So we have our s prime of s naught of x is equals to. So all this is coming from the previous video. So this is b naught plus 2 c naught x plus 3 d naught x squared. That's what we got after we differentiated. So now let's evaluate. So s prime s naught prime of 0. Evaluate for 0. This is equals to what? You're going to have a b naught plus 2c naught multiplied by 0 plus 3d naught by 0 to the power 2, which is like zeros here. So what does this tell us? This tells us that our b naught is equals to 1, because you're going to equate this to that, and this is equals to 1. Okay, so that gives us some information. So our b naught is equals to 1. So now that's what we get when you apply the initial boundary condition. The second boundary condition, okay, is at 2, of course, and you're going to say it will be s sub 1 prime of 2. What are we told? We are also told that this is also equals to 1. That's in the question. So your s sub 1 prime of x, when you differentiated, we ended up with b sub 1 plus 2c sub 1 x minus 1, okay, plus 3d sub 1 x minus 1 to the power 2. Evaluate now. So that would be s sub 1 prime of 2. Okay, what will this be? You're going to have a b sub 1 here. If you plug in a 2 here and a 2 here, this is just going to be 2c sub 1. Okay, do we have an x? No, we have substituted. What about this one? 2 minus 1 is a 1. 1 squared is still a 1, so that would be 3d 3d sub 1, like that. Then what do we do with this? We say b sub 1 plus 2c sub 1 plus 3d sub 1 is equals to a 1. This 1 that we have right here. So we can name that as our equation 5 perhaps. So we can say it's b sub 1 plus 2c sub 1 plus 3d sub 1 is equals to 1. Let me name this as equation 5. Okay. So what's the next thing that we do? The next thing that we do is just basically solving the equations. So what I'm going to do is that I know what my b naught is. I know that my b naught is equals to 1. So I'm going to substitute b naught in equation 1. Okay, so if I plug in a 1 there, it simply means what does this tell me? This tells me to say my d naught, it will be equals to minus c naught. When you plug in 1 here, you will subtract on both sides. It will be c naught plus d naught is equals to 0. So I've just made d naught the subject of the formula. I have it is equals to minus c naught. Okay, so now this that I have, I'm going to substitute it in equation 4. Where's my equation 4? It's this one here. So it will be c sub 1 is equals to c naught plus 3. What is my d naught? D naught is minus c naught. So this will be c sub 1 is equals to c naught minus 3 c naught. So c sub 1 is equals to minus 2 c naught. Is it? Yes, that's what it is equals to. So c sub 1 is equals to minus 2 c naught. So getting closer to finding some other values. So what follows after we have done this? Okay, so I'm going to substitute again this same d naught in equation 3. I was substituting in equation 4. I will do again in equation 3. So my b sub 1 will be equals to b naught plus 2 c naught plus 3 d naught is actually minus c naught, so that just becomes a minus 3 c naught. So our b sub 1 is equals to b naught minus uh, b naught minus c naught there. And I know what my b naught is. B naught is equals to a 1. We already have it here. So simply means my b sub 1 is equals to 1 minus c naught. B sub 1 is equals to 1 minus c naught. Okay. What's the second thing? What follows now, like from here? Okay. So what follows here is that from equation 2, okay, from equation 2, where is our equation 2? This is our equation 2 right here. Okay, so in this equation 2, like we have it as a b sub 1 plus c sub 1 plus d sub 1 is equals to 1. So what I'm going to do is that in place of b sub 1, I know what my b sub 1, it is equals to this one. So it is 1 minus c naught plus. What about c sub 1? C sub 1 is equals to this one. So that's just like minus 2 c naught plus. Do I have anything relating to d sub 1? No, I don't. I'll leave it the way it is, as d sub 1 is equals to 1. So you observe to say this and that cancels out. So what does this now become? This is just more like minus 3 c naught plus d sub 1, meaning if I, by the way, this is equals to 0. If I make d sub 1 the sub of the formula, it will just be d sub 1 is equals to minus 3 c naught. Okay. So what do we do from equation 5? Okay, from equation 5, here's our equation 5. I have everything that I need to substitute. B sub 1 is 1 minus c naught plus. What is my c sub 1? C sub 1 is minus 2 c naught. So this is just going to be minus 4. So that will be minus 4 c naught plus. What is my d sub 1? D sub 1 is equals to minus 3 c naught. So that's just going to be minus, actually a plus. Is it going to be a plus or a minus? Okay, this is supposed to be a plus. Sorry, not a minus. So this would be a plus 9 c naught is equals to 1. So this cancels and that cancels. So just by doing that, I obviously have that c naught is equals to 0. So c naught is equals to 0. So I have 4 of the coefficients that I'm looking for. From there, I'm able to find the others. So I have a naught, a sub 1, b naught. I'm able to find d naught from here. Okay, my d naught is equals to minus c naught. So meaning even d naught is equals to 0. Okay, what else? We have a naught, b naught, c naught, d naught. We have a sub 1. Let's go to how can we find b sub 1. So we find that our b sub 1 is equals to 1 minus c naught. What is our c naught? Our c naught is equals to 0. So meaning our let me move this the other side. Okay, it simply means if you plug in a 0 here, your b naught, so your b sub 1 is equals to 1. What about our c sub 1? Our c sub 1 is going to be equals to 0. Why am I saying 0? Because when you plug in 0 here, to be a 0. What about our d sub 1? Our d sub 1 is also going to be equals to 0 because of the presence of a c naught there. Hence, we have everything that we need. So this tells us that our s of x, our clamped cubic spline can be in the form s naught of x is equals to we have our a naught which is 0. Okay, a naught which is 0 simply means since our b naught is equals to 1, we just have x here. Similarly, our a sub 1 of x is equals to, it was supposed to be a sub 1 plus b sub 1 x minus x sub 1, and in this case our x sub 1 is a what? Is a 1, plus c sub 1 x minus 1 to the power 2 plus d sub 1 x minus 1 to the power 3. If you observe, this is a 1 like that. It's a 1 plus your b naught is a 1, so that would be x minus 1. Your c naught is a 0, d naught is a 0, so you just end up with x. So it's similar to what we got in the previous video for the natural cubic spline. So this will be x, and this is for x in the interval 0, 1, and this is for x from 1 to 2, and this is basically what we were looking for. Remember, the question was saying determine the clamped cubic spline S that interpolates the data. So this is the cubic spline, clamped cubic spline that interpolates that data that we were given. So for clarity on everything, the equations and these where we got them from, just check out the link in the description for the previous video. And this is basically how we do this one. Thank you very much for watching, and we'll catch you in the next one.